welcome to my new video. Now I'm going to show you the OR gate. The OR gate is also a fundamental digital electronic logic gate. Its output is always going to be high if one or both inputs goes high. The output only goes low when both inputs are low. So here you have the schematic on the OR gate. Here you have the truth table, you have the switch analogy and the transistor analogy. So the inputs A and B are all the output is always going to be 1 if only there is a if only there is one input. If there is more inputs that is 1, it's always going to be 1. So it only has a 0 output if all the inputs are 0. So here is the truth table. Now I'm gonna simulate the program in this program called Proteus. So when I run the program, here you have the OR gate. This is a symbol for an OR gate. The output is 0 only if all the inputs are 0. So if I put 1 here, output is 1. If I put B 1, the output is 1. If I put 1 here, both outputs for the inputs, if all the inputs are 1, the output is 1. Now here, let me just set some animation option. Okay, now here you have a switch analogy. So here, if a switch is closed, it acts as a 1. If it's open, it acts as 0. So when the both inputs are 0, or if both inputs are opened, there is no current passing here or here, so there is no closed circuit and the lamp will not glow. But if I only close one circuit like this, the lamp is going to glow because there is a current passing through A and it glows. If I open up this circuit, it acts as 0, so now on the output is the lamp, it's also 0. If I put B on 1, the current can pass here through here, it has a closed circuit, so the lamp will go. Also, if I put 1 here, current goes here, but the same amount will go back here of the current because of the first Kirchhoff's law, and the lamp glows bright. So that's the switch analogy of the OR gate. Now here we have a transistor analogy. Here we have input, here we have 5 volts always, and here we have A and B. In the first situation, I'm gonna put both on 0 volts. Now, if this is on 0 volt and this here transistor B is on 0 volts, there is no current going into the base, so the transistors are switched off, so the 5 volts can't go to the R3, so it can't get 5 volt voltage, the high input. When I run it, you will see that the output here is 0. Like I just do this schematic over here. Let me just zoom in a little bit. So here you have the output. When these transistors are blocked, there is no current passing through them, so the voltage here is 0 volts. Now when I put, for example, 5 volts here on A, and when I run the program, you will see that there is some problem. I think, yeah, it shouldn't go into the 5 volt, it should go to the collector, but maybe I didn't do the circuit very well. Let me just correct this. Okay. just delete this object. Okay. And I have to bring this on. Oh, I forgot to bring 5 volts here into the input. Sorry for that. So here we have 5 volts. Now, also sorry, let's bring it here 0 volts, the first situation. So here we're gonna constantly have 5 volts, but if both transistors are on 0, like this situation, and when I run the program, you will see that the output is gonna have 0 because both transistors are blocked, so no current goes to the resistor R3. When I put 5 volts here, for example, this second, uh, this first transistor is going to conduct, so the current goes to the R3 and it's gonna have a 4.21 volts, so it acts as a high output, even though it's not, there's some voltage loss, but the digital electronic output is going to interpret this as a high output. Okay, now when I put this back on 0 volts and bring B on 5 volts, you will also have the same situation, I think. And now also this transistor Q2 is gonna conduct, and the current goes to the R3 from here, from the collector to the emitter here, and there is a voltage dropout of 420 watts, so this acts as a high output. Now when both inputs are on 5 volts, like so, now there is a voltage dropout of something bigger than 421, now it's 425. So both transistors conduct, and there is a voltage dropout here of 425 volts, but that acts like a high output. Okay, now I'm gonna show you this situation when we have more inputs in an OR gate. So if we have 3, 4, I don't know, as many inputs as you want, the output is always going to be 0 only if the all inputs are on a low level. So if I bring just one input on 1, the output is going to be 1. So here we have that situation. Here we have with the 4 inputs, always gonna be 1, 5, always gonna be 1 if only one input is 1. Also here, yeah, and yeah, it's always gonna be 1 only if one input is on the high state or 1, but it only on output is 0 if all the inputs are on a low state or 0. Thank you for watching and see you in my next video.